Our project goal was to create a low-force endovascular stent crimper for our client WL Gore. This project has a budget of $3,000, and we have a full calendar year, 2 academic semesters to complete it.
At the very first semester, we did engineering analysis. This was done through the component of the project. So from the benchmarking devices and the research we did by ourselves, we came up with 3 categories. We have to do the analysis. One is finding the max and minimum diameter that the stent can be bring. And the second one is the radial forces required to bring the stent. And lastly, we did a power requirement, the overall direction.
And this is our failure mode and effect analysis. On the left side, we have all the process functions that we saw that it could have a failure potential, and then we took into the severity, the potential causes of it, and the current, and what we can do as a team to mitigate the failure from happening.
So this is the bottom of the design where all the magic happens. So the solution bearing is turned by 2 48-tooth sprockets that are connected to 2 10-tooth sprockets, which overall connect to another 10-tooth, and on the motor the 9-tooth sprocket to make sure that the design does not have any issues when it's turning. It does not bind up. It is all held by a 5/8 axle and 2 kilowatt bushings. You can see over here the rotary encoder. That's how we get the diameter from the device itself, which pulses 600 times per rotation. We do, like I said previously, the motor and then the motor controller. I'm going to pass this on to Alex now for the rest of the lecture.
Alright, so the power for the machine is handled by this extension cord down here, and you can see the plugs for each of the electrical components used. You can also see the emergency stop button right here, the backside of the touchscreen display. As Skylar mentioned, there's the rotary encoder, and motor driver board. The actual, all of the logic for the machine is being processed by the Arduino, which can be seen on the side of the case.
Once the device is initialized, you can select newtons or millimeters. So we're going to do 25 millimeters for this one. Click start, and the iris will go down to 25. If you'd like to change it, you can reinitialize. It's going to reset back to 0, which is 62 millimeters open. And then we can select newtons. We can do 1 for this. And it's going to crack until 1 minute.